We know that because b square equal to a square into 1 minus e square. This is the value. Or b square upon a square is equal to 1 minus e square. Or b upon a in sine inverse we can substitute. So in place of b upon a we can substitute and root 1 minus e square. That can be the answer. This is the final answer. Okay, if there is any minor mistake or some numerical value or this constant values a and b, that can be there, but it is clear to the process must be clear. Okay, now let me take question number 5. What is question number 5 say? Let me check it. Okay, now question number 5 is of what kind? Now it says question number 5 here. This is 5th question. 6th question is this, and 7th is this. This is 7th one. This is 6th one. 5th one is this. The figure bounded by a quadrant of a circle of radius a, alright, and the tangents at its extremities revolved about one of the tangents. Prove that the volume of the solid generated is this. Now try to understand. There is a circle of radius a. Let me take this is the quadrant of the circle. Now tangent at the quadrant of the circle is this is the tangent here. One of the tangent is this. If I take the circle like this, this circle is like this. The circle here, and one tangent is this. Now it says that this curve is revolved around the tangent, this arc. These two tangents are there. This tangent, and this tangent. Now this tangent, this curve which is between the two tangents is revolved around one of the tangents, one of the extremity tangents at extremities. It says the figure bounded by a quadrant of a circle. Figure bounded by a quadrant of a circle means 1/4 part of a circle. Quadrant means this is the, let me take AB. AB is the quadrant here of the circle. Now this involves the two tangents at the vertex, this tangent. Now this arc or area between this tangent and this arc is revolved around one of the tangents. Now this one tangent and this is another tangent. Now if this arc is revolved, quadrant arc is revolved around this tangent, this will make this kind of figure here, a peculiar kind of. This is the figure here total. Got the point? Only one of the quadrants here, not total figure. Otherwise, here could also be there like that. Okay, in elliptical figure. In this case, in the 5th question, the figure bounded by a quadrant of a circle of radius a. Okay, so equation of the circle is x square plus y square equal to a square. Let me take a is the radius of the circle. Now it says, and of the radius of a and the tangents at its extremities. This is extremity. This is extremity. At the two extremities of the quadrant of its circle. Okay, the two extremities are there. The tangents are drawn, and the tangents at its extremities revolve about one of the tangents. So we have revolved this quadrant of the circle between the tangents around one of the tangents. So let me take this tangent here, and we are revolving this around this. Again, let me take this is a strip here, P, and this is Q point. This is M, and this is M is this, and this is N point here. Now we will find out this is A here, A point, A0 because radius is A. Now if I drop a perpendicular from P to this x-axis, this is center of the circle, this is x-axis, y-axis, y-axis, x-axis. Try to understand. Now what is this length here? And this length, or this is strip of the length, PM, and this is, suppose let me take P, O, P, Q, or let me take here P, M, N, Q, S, let me take here, this is A. What is the length of this SA? SA is equal to PM. So here PM is equal to SA. We have taken the strip PM. Okay, this is question number 5. Sorry, question number 5 here. Let the equation of the circle, this equation of the circle here, which is given to us with radius A, is x square plus y square is equal to A square with radius A. With radius A, this is with radius A. Now it is revolved around one of the tangents, and this, let me take A. This is AST. Let me take here this point. AT is one of the tangents, and this is under tangent. And this tangent is, let me take here AT U point. BU. BU is under tangent. BU and AT are the two tangents at the extremities. Here, the solution we are finding out. Solution here, the two tangents at the extremities of the quadrant of the circle, at A and B. Here the extremities A and B. Tangents are, the two tangents are, we have taken AT and BU. Here the two tangents. Now the area between tangent and this quadrant, this area between the quadrant of the circle. Okay, this is AB arc we have taken. The quadrant of the circle, that is AB, quadrant is AB here, arc of the circle AB is revolved around or about the tangent, AT tangent we have revolved around. Got the point? So this is the figure we have obtained. So in this we have taken this strip. Let me take PM and Q is the strip here. So here Px by, we have taken the point. Okay, Px by a point on the circle here, Px by a point on the circle, forming a strip. What is that? Strip PM and Q will have the volume, elementary volume. What is the volume of this? This will be pi into. Now what is the distance here? This is A and this is x, so this is A minus x here. Got the point? So this is A minus x here, because A is the radius. This is A minus x into whole square into d by or delta by here. This I have taken delta y or d by. This is delta y. Let me take. Limits still we are not applied. Now what are the limits here? 0 to A, because A is the radius of the circle. So this is the height radius, which is equal to this. So y coordinate will be 0 to A. Okay, simple. This limit we have to substitute. Now let me substitute here. Therefore, the final volume of this will be, therefore the volume of the solid generated will be this much. 0 to A, because y coordinate here is 0, and this is A here. 0 to A, we have to take this limits. Okay, so between 0 to A, we have taken this 0 to A limits. For y coordinate, this pi into A minus x whole square into d by now. But limits are for y, this is in x. Again we have to convert x into y. So from this x square equal to, but x square equal to a square minus y square. This we will substitute here. Let me substitute that. Similarly, here we have to open this pi 0 to a limit. This is a square minus twice ax plus x square into d pi. So from equation of the circle, this we have obtained from first equation. Okay, from first, but x square equal to a square y square for the circle. So we have to substitute here value of x, because we have to convert this into y variable, because limits are for y, d by is there, so x is converted into y. Here this is a square 0 to a limit, first is a square minus twice a, x is under root a square minus y square. Try to understand. Again this is a square minus y square and x value plus x square. X square is nothing but a square minus y square. This is a square plus a square twice a square into d by limits 0 to a. Only this is the volume. Let me solve it further. Therefore, V volume of this figure will be pi. Okay, now let me integrate them. Integration of this will be pi here outside. A square twice a square. This is twice a square into y minus sign. This is twice a. This is step. Under root a square minus y square is integrated as 1 upon 2 into y. This is with minus sign. Okay, this value is for this only. This plus sign I was taking, sorry, that negative sign. But that 1.2 was not taken to that side. I'm sorry. In the previous question, I multiplied this by minus 2a to that one also. That is not possible, because this was the independent term. I'm sorry. In the previous question, this last step, it was of y square something. That was y cube upon 3. Okay, that I just took wrongly. I'm sorry. Because this is only for this value. Minus 2a is for this value only. This minus 2a. Okay, minus 2a is only for these two steps. This is under root by a square minus y square. First integration, then plus sign. This is 1.2 into a square sine inverse y upon a. Okay, this is integrated. Limits we will substitute 0 to a, no problem. Here also 0 to a, and plus sign this last value minus y square. This is minus sign y cube upon 3, and this is having independent 0 to a. I mean limits are independent for this. I mean same value, same limits I mean. Now let me take the final answer. In the previous question also I multiplied by minus 2a in between to this also. I'm sorry, this was the mistake there. So that was some mistake. Now let me further. So this is simpler, same type of question, but having not so 0 to only at a we have to substitute here, because others at 0 every term will be 0. Only this value a, this is twice a cube. Okay, minus 2a is out of this. First step will be a square minus a square is 0. Sorry, because at a square it will be 0. A square similarly at I think b square, but that was b square on a square. I'm sorry. This is a square. If I substitute here, it is 0 at upper limit. At lower limit also it will be 0. This term will be 0 in both the cases. Sorry. Because if I put a, this is a square minus y square, so a square minus a square 0. At 0 it will be 0. So in both the cases it is 0. Only now this term will be obtained. This is 1.2a to a square into this is sine inverse 1. A upon a, that means 1. At 0, this is 0 and this is also 0. Everything is 0. Every term will be 0 at 0. So only these two steps are obtained. No problem. Because at these two terms, at 0, it is 0 by into something 0. Sin 0 is 0. At A this was 0, but at A only this minus 2A, I'm sorry, 1.2A square into minus 2A is also there. This minus 2 into sine, this is minus 2A into sine of this. This is to be multiplied by minus 2A also in this case. When A substituted, minus 2A into 1.2A square into sine inverse A upon A, that means 1 only. Okay, so these two steps are there. I is 2A cube minus, this is multiplied to 2 to cancel out, this is minus A cube. Sine inverse 1 is pi by 2. Okay. So what is this? Pi A cube. This is pi left over A cube. Let me take common. Pi A cube. A cube I have taken outside. It is nothing but 2 minus pi upon 2. 2 minus pi upon 2. Should be to prove this. Okay, so this is pi A cube. Okay, this is 5 by 3 is coming. Sorry, this step. Sorry, left. So minus 1.3 is also there. So this is minus 1.3. For A cube I have taken common. This is 1.3. This is 2 by 3 to the 6 minus 5 by 3. Same answer there. I'm sorry. This minus 1.3 was also there. It will be pi A cube into 3 to the 6 minus 1 is 5 by 3 minus pi by 2. Same answer is obtained. Pi by 2 into this 5 by 3, because minus 1.3 I left here. A upon this A cube upon 3, which is negative. This was here. So 1.3. This was also there. So 1.3 and 2 minus 1.3, getting 5 by 3. Same answer is obtained. Okay, so this is the value here. Final answer, so hence proved. So same value has been proved. Same is obtained. 5 by 3 minus 1.2 into pi A cube. Same answer is obtained. Okay, so this is the answer. This is minus 1.3 is also here. That is the point. Okay, then see you. After 5 minutes, I'll take the next question. Okay, then see you.